Hi everyone, today we are going to learn Curve Snap. It's a software which is used for digitizing a curve or any image. Suppose you have a curve which has a data in a book or in a off-print journal, but you have to digitize the curve and you have to use the data in your research or in your project. So you can use this software to just grab the data in the picture or in the image as a curve. So for that you have to download CurveSnap. It's a very small software. Its size is 4.5 megabytes. There are lots of sources. You can go to xoofee.com, which is zoofee.com 2012. I will give the link below the video. There you can go and click on the CurveSnap version 1.1, and it will download almost instantly. It will take only some seconds. It depends on how much speed you have in your internet. So here you can see that it's only 4.5 megabytes, and I have downloaded the software. And the funny thing is you don't have to install the software. It's like a portable software where you can take it in any computer and you can use it anywhere. So here is the files that you will download. You have to extract the CurveSnap using a WinRAR or WinZip software. So these are the files that you will get in the zip file. So this curvesnap.exe is the actual file. It's the extension file. You have to, if you click that, then it will open a curvesnap window. So you can see the window. There are some options: file, calibrate, edit, curve, help. So I will go through one by one and how to use CurveSnap to capture any data from a curve. So for this tutorial, I have selected a very good and very standard image. This is the image that I have selected. So it has almost all the options that you can use in the CurveSnap. So it's like a stress displacement data that I have got from a book. So I have just taken a screenshot of the image, and now I am just going to digitize the curve. So I'm by saying digitizing the curve, I'm just saying that you can get the x and y point, or x and y point of a curve as a digital value. What you can just download in Microsoft Excel or SPSS or any kinds of data software. So to do that, first of all, you have to load the image. So I will go through all the options using this example, so it will be much more easier for you to understand. So first of all, you have to open the file. So you will just go to the folder where you have saved uh, the file. So here I have just saved at CurveSnap version 1.1. It doesn't have to be in the folder, you can keep it anywhere. So I'm just opening it, so you can see that it is loaded in the CurveSnap. So here there is P1 and P2. So if you take your cursor there, you can say that there is a name of this P1 button, which is first calibrating point, and P2 is the second calibrating point. So the first thing that you have to do is you have to set two calibrating points. So what calibrating points will do is it will just subdivide the whole image in between these 2 points in a very small pixel areas, and it will automatically calculate the pixel areas, and it will just digitize the area in between these 2 points, so that you can take any points in between these 2 points. So first click on P1, and then you have to select 1 point. So usually what I do is I select the 0 0 point for the first calibration point, and I take the maximum x and y point as the second calibration point. So here 0 0 is in between this place. So when you will when you will click in the image, you can see that there is like another pop-up window which says coordinates. So here there are like left, right, up and down. You can just change the point this way, and you can select a proper point. So I'm just assuming this is the proper 0 0 point. So you have to give the value as 0 and 0 xy and click OK. So you can see the cross mark, red cross mark at the 0 0 point. Then you will click at the second calibrating point, and what I suggest is to take the maximum xy point. So in this case, this is the maximum xy point. So click here, then you can say that you can see that it's a little bit at the right of the image. So just use this left and right button to go to the exact point, and then just give the value of x 0.7 and y 30 and click OK. So now you can see that at the top of at the top left corner of the image there are 2 points, 0 0 and 0.730. So the red color is the first calibrating point, and the green color is the second calibrating point. So after doing the calibration of the image, so that means all the points inside these rectangles are now in the memory of the software. So you can now use these options to just capture the data. So first of all, I will go through one by one. So my favorite one is actually choose curve by color. It has, you can see that in the curve there are like black, blue, red, and green. Each each color has different values. So right now when you select choose curve by color and then click on the red color, so see at the right it just digitized the whole red curve. So there you can see that there is a funny thing happened here. This is actually the red from the legend, and the spikes here is due to the red spike due to the legend colors. It has actually averaged the values in between the legend red and the actual curve red. So what we are going to do for that is to use the eraser button. So if you take the eraser button and then erase the red portion of the legend, then you can see that this curve is now more smoother than before. These ups and downs, these occur due to the red points, due to the red levels in the uh, image area. So what happened is this software takes all the reds in the image and then digitize all the points. So that's why it cannot reject the other reds, which is like the circles. So that's why they just take all of the points, red points, and then make an average. But it's a very almost it's a perfect curve. You can see that the maximum is at 24 and it is at around 24, and the x-axis, the maximum x-axis point is 0.6, and you can see that it's almost at 0.6. So now you have captured the red curve. If you want to save the data, you can obviously save it. You have to go to the curve options and select copy data. At the topmost corner of the pop-up window, you can see that all the values are there. These are the values that are captured from the image. So you can use any kinds of these three kinds of separator: tab, space, and comma. Usually I use comma, which is very useful for Excel conversion. And then just click save. So you can give any name, red curve data dot txt file, and save it. So this file is saved. I can show you later but how to extract this .text file in the Excel file. So right now I'm just clearing all the data, so you can go to the curve and clear section. So all the data are cleared. So remember the red the points that we have extracted, it is saved. We have just cleared all the data in the software. So now we will again use the choose curve by color, and we will click on black. So let's see what happens. So you can see that there are lots of ups and downs, lots of spikes in the curve. That is actually due to the all blacks in the curve. There are lots of blacks like the legends and also the X levels and Y levels. Everything is written in black, so it has taken all the black in the image and then converted it. Then so here you can see that these are all the blacks in the image. So there are lots of blacks, and it has just made um, an average of all the colors. So for in this situation, what you can do is first clear the selection, and I would suggest you to try to try erase all the blacks in the image. So I will do a little bit. I will not waste time just showing how to erase all the data. So I will just only erase the Y levels and then do the curve snapping again, just to show you that all the blacks are gone and the data are a little bit changed from what you have seen earlier. Okay, I will try to do everything just to show you, because almost all the curves that you can find in books and or in any journal or print journal, the all will be maybe in black ink, so it will be hard to use color curve snapping. So I'm just going to show you how to do curve snapping with only black color. So there are some blacks here, and here. So in one case you just have to keep the in this case you just have to keep the black in the curve and just delete all the blacks that you have in your image. So right now it's almost clear. So now we can go to choose by color and click on the black. So now it's almost clear. You can see there are some spikes, maybe there are some blacks. So here you can see, okay, that's fine. And now it's almost gone. Yeah, okay. Yeah, I'm pretty satisfied with this result. It's almost smooth. So okay, so we will do the same thing, go curve, copy data, and use comma, tab, space, whatever you want, and save it as like black curve data or whatever you want, txt. Okay, save. I'm sorry. So we have saved the black data. So now what I will do, like I will go to curve, clear selection, and I will try to use some other options like choose by rectangle. So if you want to take only data for a specific set of points, you can use the rectangle one. So like right now I just want to take data from these points. So the selection has taken uh, points inside the rectangle and then made an average of the points, an average of the values. So if you use the choose by color of choose by area, then you cannot actually distinguish between two colors. So if you have colors, I would suggest you to use the color option, but if you don't have any color, then you can use the rectangle uh, options. And there is another option, choose single data point. So if you want only one data point, like here you just want to see which one is the maximum point, just click on the point, that's it. So it's very easy to take only one point. So here you can see that the data is the x value is 0.11 and the y value is 24. So yes, there are some options that you can play with, but usually this is the basic of curve snap. You can do calibration, you can again reset everything and do everything from the beginning. You can just change the reference point anytime you want. So suppose here I say that okay, I have done some mistake setting up the point, so I will just go and set up the point. So you can see that the first reference point has been changed. So you can play with it anytime, and you can save the image, save the data, everything. So I think when you transfer all the data in a text file, I would suggest you to transfer the data in an Excel file. So I will just show you briefly how to do that. Okay, so I have opened an empty Excel file. So I will go to the data. So I'm using Excel 2013. So in Excel 2013, you have to go to the data tab, go to from text, and go to the directory where you have saved your data. So here the red curve data, black curve data. So I am just importing the red curve data. So it will ask you whether you want to use delimited or not. So I will say yes, delimited, and then say next, and select comma as your data separator. So it will separate the data from one another, which will be useful to use in Excel. So right now here, this is the data that we have actually extracted from an image using the curve snap. So if you just want to check whether we have extracted right data or not, you can just plot the data and just check whether we are okay or not. Okay, let me just change, it will be easier to understand this way. So here this is the data that we have extracted from using curve snap. So you can play with the software. You may have to calibrate the software properly to get proper data, and it will work almost precisely for you every time.